Welcome back to another session in the TAE certification series. Today we will go through section 7.2, which focuses on confirming or validating the automated test suite. So let's begin. Automated test suites need to be tested for completeness. Okay, so this is making sure that all essential functionalities and scenarios, they are covered in the automated test suite, because lack of coverage can miss critical issues, which can then impact the software reliability. The second one is consistency. This is making sure that the test suite produces uniform results across different environments and devices, because inconsistencies can lead to unreliable testing outcomes. And the third one is correct behavior. So this is verifying that the software operates as expected based on defined requirements. Incorrect behavior can affect functionality and also the user experience. Okay, so the next point is different kinds of verification checks can be applied to make sure the automated test suite is up and running at any given time, or to determine that it is fit for use. Okay, there are a number of steps that can be taken to verify the automated test suite. These include: number one, executing test scripts with known passes and failures. Number two, checking the test suite. 3, verifying new tests that focus on new features of the framework. 4, considering the repeatability of test. And 5, checking that there are enough verification points in the automated test suite. Now let's go through all these 5 steps in detail. The first one is executing test scripts with known passes and failures. And the first point is when tests fail unexpectedly. When non-passing test cases fail, it is immediately clear that something is fundamentally wrong and should be fixed as soon as possible. So if you are playing a video game and suddenly your character cannot jump when they are supposed to, that's a clear sign that something definitely is not right with the game and it needs to be fixed. The next one is identifying failed tests that passed. So when a test suite passes, even though it should have failed, it is necessary to identify the test case that did not function correctly. Okay, now still we can take an example of the same game we are playing. So imagine that playing a specific level in a game where you are supposed to find hidden treasures. So even though the game shows that you have found all the treasures, you know that there is one that is missed. So now the missed hidden treasure represents the test case that passed but should have actually failed due to some underlying issue, and that's what needs to be found out. Then we have checking test processes. It is important to verify the correct generation of log files, performance data, setup and tear down of the test case or script. Okay, so there are 3 things, so let's break it up. So first one is it is important to verify the correct generation of log files. Okay, so in the game, logging your progress could be similar to the game keeping track of your achievements or the missions you have completed. So just like the game should accurately record what you have achieved, in testing it is important that the system accurately records the steps taken during testing, like creating logs so that it can track the testing progress. The next one is the performance data. So in a video game, performance data might reflect how smoothly the game runs or how fast you are able to complete the task. So in the same way, it is essential to track that how efficiently the system performs under various conditions. And the last bit is setup and tear down of the test case or script. So setting up and tearing down a test case or a script can be compared to the game setup before starting, let's say, any race or any mission, and cleaning up afterward. So it is like making sure that everything is properly prepared for the test and returning things to their initial state after the test completes, just like preparing for a mission and then wrapping it up when finished. Trying different test types. It is also helpful to execute a few tests from different test types and levels: functional test, performance test, component test, etc. Okay, so let's split this as well. So the functional test. Think of completing missions or all tasks in the game. So each task tests specific aspects like delivering an item or maybe defeating an enemy. So in the same way, functional test checks that if different parts of the softwares like features and functions, they are working as expected. Now coming on to the performance test. So in a game, this would be like testing how smoothly it runs, especially during any intense action scenes, or let's say with multiple character on the screen. So in the same way, performance test checks that how the software behaves under various conditions, like handling heavy traffic on the website from multiple users accessing an application simultaneously. And the third part is the component test. So again, taking the example of the game, this could be examining specific abilities or the items which you have and making sure that they are working correctly. So in the same way, component test focus on testing individual components or smaller parts of the software, like checking that if a specific module or function is operating correctly on its own. So trying different types of different test types in software testing is just like experiencing different challenges or scenarios in a game. So each test type, it assesses a specific aspect of the software, just like each level or challenge in a game test different skills or abilities. Moving on to number 2, checking the test suite. Check the test suite for completeness. This means that you review the entire set of test cases to make sure that they cover all expected scenarios. And this involves making sure that every test case has expected outcomes defined and sufficient test data is available. Then we have correct version with the framework and SUT. This involves making sure that the test suite matches the correct version of both the testing framework which is being used, which will include the testing tools, test scripts, etc., and the SUT, which is the system under test. It is important to align the test suite with the right software versions to avoid any discrepancies or errors during testing. Then we have number 3, verifying new tests that focus on new features of the framework. So this is about the implementation of a new feature in a test automation solution and the necessary steps which needs to be taken to make sure that it's functioning properly. So let's have a look. The first time a new feature of the TAS is actually being used in the test cases, it should be verified and monitored closely to ensure the feature is working correctly. Okay, so adding a new feature to the test automation solution means introducing a capability or a function that was not there before, or maybe it was there before but it was not automated. So it will be either of these two scenarios. So we need to confirm that the newly added feature is working as expected. Monitoring closely means keeping a close eye on how the new feature behaves in the test cases. It requires continuous monitoring to catch any problems, mistakes, or unexpected actions that might happen because of adding this new feature. So the ultimate goal is to make sure that the new feature is functioning correctly within the automated test suite. This means that it works as expected and does not create any problems for the existing functions or test cases. Then we have number 4, considering repeatability of tests. When repeating test, the result or verdict of the test should always be the same. This means that each time we run a test, it should always give the same result. For example, if we test a calculator application and we add 2 plus 2, it should always give the answer as 4 whenever we run that specific test. The next point is having test cases in the test set which do not give a reliable result. For example, race conditions could be moved from the active automated test suite and analyzed separately to find the root cause. Otherwise, time will be spent repeatedly on these tests run to analyze the problem. Okay, so some tests might not consistently give the right results, like when a race condition occurs. So let's first understand that what is a race condition. So race condition occurs in software when the outcome of a process depends on the timing or maybe sequence of events. So this means that the result of an operation is affected by the timing of how different parts of the program are executed simultaneously. So to understand this better, let's take an example of an online banking application. So let's say that we have a scenario where two users are trying to deposit money into the same account at the same time. Now, if the application does not handle the situation carefully, it might actually result in an incorrect total balance because both deposit actions were executed simultaneously, and it can cause issues in updating the balance. So now we understand that what are the race conditions. So the tests which are affected by the race conditions, they might sometimes pass and sometimes fail. Means that they are not giving the consistent outcomes. So it is important to identify and separate these unreliable tests so that we can analyze them and understand what is causing the inconsistency in results, and then address the issue or issues which are causing the race conditions for a more reliable testing process. So I hope that this one is clear. Then the next point is intermittent failures need to be analyzed. The problem can be in the test case itself or in the framework, or it might even be an issue in the SUT. Okay, so now over here, there are 3 parts because a problem can be in the test case, in the framework, or in the SUT. So let's take an example of a login test which fails occasionally, even with the correct credentials. So let's see that first of all, how it can be a test issue. So the test might be incorrectly designed, means like the test case is not written properly. It can have wrong assumptions about the expected login outcome or incorrect verification steps. For example, let's say that the test is designed in a way that the test thinks that there should be an error message when logging in, even if the login is successful. So when the login works fine without any errors, just like it's supposed to do, the test mistakenly believes that something went wrong because it was expecting an error message that didn't show up. So this was an issue in the way the test case was designed. Now let's have a look at the framework issue. So the scenario is that the login test fails intermittently and seems like that it's unrelated to the provided credentials. So the test framework might have compatibility issues or limitations, which is causing failures in the login test across different devices or different environments. Now let's see the SUT scenario. So So it can be that the login test encounters intermittent failures after recent updates to the application. So for example, a bug introduced during the application update affects the login process, which causes occasional failures even with the correct credentials due to an error in handling, let's say, user session or data. So to figure out what's wrong, we need to look closely at the problems and check that if they are because of how the test is set up, or are there any issues with the testing tools, or there are problems with the updated application. So this investigation helps find the main reason behind the issues. The next point is log file analysis of the test case, framework, and SUT can identify the root cause of the problem. Debugging may also be necessary. So to find out that when intermittent failures happen, we can check detailed records, which are log files of what's happening during the test, the testing framework and the software which is being tested. So it's just like checking a detailed diary to understand that where things went wrong. And then we have support from the test analyst, software developer, and domain expert may be needed to find the root cause. So sometimes finding the reason behind test failures might need input from different experts, like the test analyst who understands the test process, or the software developer who has actually built the software, or maybe the domain expert who knows the business needs. So let's say if you have to fix a bug in a car, you might need help from a mechanic, an engineer, and also a designer to understand and then solve the issue. So all these practices helps to make sure that tests are reliable and any issues causing test failures are understood and fixed effectively. And the last one is checking that there are enough verification points in the automated test suite and/or test cases. The first point is it must be possible to verify that the automated test suite has been executed and has achieved the expected results. So this is important because it builds trust that the testing process is reliable and the software is working correctly. Evidence must be provided to ensure the test suite and/or test cases have run as expected. In software testing, providing evidence is like keeping a detailed record of the steps taken during testing. It is important to show that the tests were carried out properly and make sure that the software functions as expected. This evidence can include logging at the start and end of each test case, recording the test execution status for each completed test case, and verification that the post conditions have been achieved, etc. So these actions like keeping logs or noting down the results and checking expected conditions, they act as proof that the automated testing was done correctly and have given the correct results. We have now completed chapter number 7, and in next session we will do some practice questions. Till then, take care and happy testing.